Welcome everyone. Today I'll be talking about managing Terraform Cloud workspaces using the TFE Terraform provider. And before we dive into it more, let's first start with what Terraform Cloud is and how it compares to the most commonly known OSS version of Terraform that most of the people is familiar with. So Terraform Cloud is a completely managed SaaS solution that exposes a web GUI, an API, and a streamlined workflow of running your infrastructure as a code. In addition to that, it also offers a private modules registry. It delegates away managing the state files and locking of those, and it also knows how to trigger and run remote operations in the cloud for you. So basically, when you do your Terraform runs, it will execute the Terraform run in the SaaS solution instead of your local environment. It also offers a granular way of how to collaborate within the team. So you can set specific permissions for your team members to collaborate together, and also knows how to connect to your VCS, so versioning control systems, in order to trigger your pipelines based on changes that you push into your repositories. So who am I? I'm a senior consultant at the Scale Factory. My name is Marko, and we are a remote-first AWS consultancy working exclusively with SaaS businesses. My background is mostly ops. I also did some programming in my previous life. I'm also a HashiCorp ambassador, an open source contributor, and a supporter. I'm also a big fan of simplifying and automating things, as well as hiking, cycling, and pre-pandemic also a lot of traveling as well. So let's first start with some topics that we're going to cover today. We already looked at the Terraform Cloud, to see what it covers, what kind of solution it is. We're going to continue with looking at what SaaS platforms and shifting left means for empowering users, and how we can utilize those platforms in order to get better and a smoother experience for the end engineers running the infrastructure as a code. We're going to continue looking at our Terraform Cloud adoption journey. We're going to look how we elevated the API access to the platform and use TFE provider to automate our workflows. And we're going to continue looking how we use reuse the approach with module abstraction and created reusable code in order to scale up easier. Afterwards, we're going to continue with a demo and an implementation example. And I'm going to wrap it up with some takeaways and learnings from our experience adopting the TFE provider and modularizing that using the Terraform modules. So let's first start with having a look what SaaS platforms, specific platforms such as Terraform Cloud, can help us with, and how they can help us mostly shifting left and moving the responsibility more towards the end users, in our case engineers that are provisioning infrastructure as a code. So mostly we would use those platforms to delegate the responsibility and complexity away from the users. It usually comes with a streamlined workflow and built-in checks. So for example, we eliminate the margin for human error, and it also usually reduces the team friction. So we push down the ownership down to users responsible for provisioning infrastructure, and at the same time breaking down silos where interaction between teams is minimized to a level only as necessary. So in a nutshell, we could say using SaaS platforms such as Terraform Cloud mostly empower users to deliver more with less, and move the ownership of their changes down to self-provision services, where they don't need to seek a lot of approvals and other interactions with other teams. But this also raises a question as well. Is the platform itself enough? Is it enough to just have a SaaS platform such as Terraform Cloud to fully automate and delegate all the things away from us? So with that, let's have a look how it all started in our journey and how we actually got exposed and how we actually got familiar with Terraform platform. When it was initially announced at HashiConf 2019 and shortly afterwards made generally available, of course, as a SaaS consultancy, we immediately jumped on the opportunity to give it a go and start testing and kind of, seeing how it all works, how it all connects, and how it all fits within our story, and also when we are working with our customers, how this actually can help them achieve more. So naturally, we started with manual configuration and kind of twisting some knobs and specific buttons and see how it all works. And as our projects grew and as our customers grew with the infrastructures that needs to be provisioned to Terraform Cloud, the complexity also quickly increased. And also as part of that, we noticed that operational overhead managing the configuration of the Terraform Cloud itself, such as workspaces and configuration related to that, quickly kind of overgrew the initial kind of tinkering with it. So we thought this was a really good kind of time point in time where we wanted to stop a bit, rethink, circle back, and try to, see if there is anything else that we can do to optimize this workflow and kind of automate it even a bit more. So shortly afterwards, we kind of, found about the Terraform TFE provider, which seems to be an official provider for Terraform Cloud or enterprise that you might run on-prem. It's an open source project. It does support most of the Terraform Cloud or enterprise resources or data sources. It offers us a really nice programmatic access using the API endpoints of the SaaS platform, and also enables us to automate the manual configuration that we did before. And at the same time, what is a really powerful feature with it as well, because it's a Terraform provider, we can use familiar and also kind of approach that we all kind of comfortable with, which is infrastructure as a code, by using HCL, which is HashiCorp Configuration Language version 2, to configure Terraform Cloud itself. So if you think of it, we're using Terraform to configure Terraform Cloud. Seems kind of weird, but at the same time also a cool feature as well, right? So as we start using the Terraform TFE provider, everything falls into place. We were using Terraform to configure our configurations of the Terraform Cloud, but we still notice that that doesn't eliminate the code duplication and the things that we needed to kind of repeat over again whenever we try to configure a resource within the Terraform Cloud. So naturally, because this is a Terraform code, the next step would be, we thought, let's go and package it as a module, right? Because this is, a really nice way of keeping your code dry, easily accessible, and because it's a container for lightweight abstraction of complexity, you can easily reuse the code, but at the same time, because we're using Terraform Cloud, you can publish it either in the public or private registry within the Terraform Cloud. So if you publish it on the public registry, you could kind of widen your community reach. In our case, mostly with our customers, they were kind of constrained to what they can publish, so they use the private registry, but still, it enabled them to use the repository for easy reusable code they used for configuring the rest of their workspaces. Of course, you can use a really simple way of versioning your modules using Git tags and publish those in your Git repo, which are immediately available in the Terraform registry. And your code is easily available and shareable across your team or even beyond the organization if needed as well. As I mentioned before, this is a really good way of keeping your code dry and easily accessible, and definitely eliminates all the concerns we have before. So let's quickly have a look at the kind of Terraform code sample, how to use the module that we're gonna look into more detail during our demo later on. So first of all, we need to define a backend. In our case, we're using Terraform Cloud, so the backend would be a remote backend. We need to specify our organization and a workspace where this is gonna be run. And then, like I mentioned before, it will use the Terraform module that we create, and that will be actually used, and we'll be feeding it parameters in order to configure the rest of the workspaces and configuration for those. So before we dive into demo, let's look how it's going right now for us. So by using a Terraform module and a TFE Terraform provider, we ended up with a fully automated self-provisioning process, which is Git-driven, and it offers us a central configuration point using the HCL2. The code is reproducible and highly reusable. So by just, calling it up from the Terraform registry, you can easily consume that module and use it for any kind of, specific configuration or workloads that you will need. And it's built up with the security in mind. So all the sensitive values are safely stored either within the Terraform Cloud using the Vault in the background, or using an external secrets provider such as Vault again, or maybe if you work with AWS Secrets Manager or equivalent with other providers. So before we look at some code examples and the demo, let's quickly have a look what we're going to show today. So for the demo today, we're going to use a VCS system, in our case GitHub, where we're going to have a repository where our configuration code for Terraform Cloud will live. So we will have Terraform Cloud workspace defined, which is going to be used to configure the rest of the workspaces. And in order to achieve that, as you can see on the left, we're going to use a private TFE registry where our Terraform module will be published. And we're going to use that as a reusable piece of code to kind of provision the rest of the workspaces that we're going to link to the same VCS repo, but they're going to be triggered from different subfolders. And of course, everything will be run and triggered in a Terraform Cloud SaaS managed solution. Okay, it's time for demo. So before we look at the specifics and how we organized our GitHub repository here, let's quickly switch to the Terraform Cloud Consul for a bit and look what we configured here. So ignoring the first two workspaces, I have defined a TFE workspace, which is going to be used to configure the rest of the workspaces within Terraform Cloud. So let's quickly have a look how this is all kind of configured and set up. So this workspace is linked to my GitHub repository, and it's gonna be triggered on Terraform Cloud subfolder. We're passing down a couple of tokens. So specifically here, we're using the TFE token, which is used to access the Terraform Cloud API endpoints. And we're also passing down a couple of other variables in order to access our AWS environment as well. So let's quickly have a look at the module as well that we're going to use as part of this demo. We're going to use a module called Workspaces, which also lives in the GitHub repo. It's a different repo. So let's quickly have a look what we have defined in here. We're not going to go into details how everything was implemented, but let's have a really quick overview how this actually works. So from a high level perspective, we're feeding it variable workspaces, which it's going to use to define all the rest of the workspaces that we define. It's going to link them to a specific working directory within the same VCS system, and also link them to the VCS system as well, using the same OAuth token and identifier that we use for the configuration workspace. And also there's an option to configure notifications and triggers as well. Okay. Let's have a quick look what we define in our repo. So it's a really simple structure where we have a Terraform top root folder, and within that we are defining a cloud folder, which is going to be used to configure our Terraform Cloud workspaces from. And then we have two other test workspaces or test folders that are going to be linked to the workspaces that we're going to provision using our Terraform code. So if we quickly have a look at our code in the Terraform Workspaces workspace, we're using the module previously shown that lives in the registry. We're feeding it down with some of the parameters needed to be used in order to provision and connect to the Terraform Cloud. And we're also defining a couple of variables, such as test variable for HashiConf global. And we're passing down some secure variables, which are safely encrypted and encoded, so people cannot snoop on your sensitive credentials for AWS, for example. If we have a look at the variables that we're passing down to that module, we are defining two workspaces linked to different folders in Git repo. and we're setting a trigger that will trigger the workspace number 2 when workspace number 1 successfully applies. Let's quickly have a look how our workspaces, what code are we using in our workspaces. So it's a really simple thing. We are provisioning S3 bucket and defining a random name for it. Okay, so let's go ahead and commit that code into our repo and push it to the main branch, because we're just gonna go YOLO here and just gonna push to the main branch. Obviously that's not suggested for the production workloads. So as you can see here, as soon as we push it to the main branch, the TFE Workspaces workspace is actually being triggered, and it immediately starts planning our code from that repository or subfolder which we define. As you can see here, the plan succeeded, and what it's showing us here, it's trying to provision 2 Terraform Cloud workspaces linked to the same repo but different folders, and it's also setting a couple of parameters such as test variables and AWS access and secret keys. We're also setting a trigger, so when the workspace test 1 is successfully run, it's going to trigger the workspace test 2. So let's go ahead and apply that. And as this one is applying, let's observe what happens in Terraform Cloud Consul. So as soon as this applies, it will use the TFE token in order to connect to the API endpoint and immediately create 2 workspaces for us, which are called test 1 and test 2, the same way how we defined it in the Terraform variables seen before. So if we have a look at the test 2 workspace right now, which is currently being queued due to the first one still being planned, but let's see if everything was set correctly in order how we want it to be. So first, let's see the versioning control system. So obviously it's linked to the same workspace, the same GitHub repo, linked to the different folder, which is test 2, where the code's gonna live, and it's currently being planned. And then there are variables that we kind of set in our configuration repo that also have been set for this particular Terraform workspace for us. Okay, in the meanwhile, it actually successfully planned, so let's inspect the plan for this current run. As you can see, it's provisioning, like I said, the S3 bucket, and it's generating a random name using a random path resource. So let's go ahead and apply this specific plan and let it provision our infrastructure using the keys that we set in the AWS cloud. So as this workspace is running, let's go back and inspect the test 1 workspace, which also successfully planned. So let's go ahead and quickly look what has been planned. This one is much simpler, so we're just using a random path resource and we're not provisioning anything in AWS. But this one actually is linked to test 2, so we're using a trigger on a successful run. This one will trigger our next one as well, as we configured before as well. So let's go ahead and approve this one. So you can see the previous actually successfully applied, and this one is currently running and applying the code. But what we are interested here is to see after this one applies, if this actually will trigger the run on test 2. And as you can see, the trigger was obviously successfully configured, and it triggered the planning phase for our test 2 workspace. Because we haven't pushed any of the code change in that specific repo, it's not going to produce anything in the plan, and it will just stop by saying no infrastructure changes, so nothing else needed for this phase. Okay. So before we clean up the workspaces, let's quickly queue a destroy plan for the test 2, because by just destroying our workspace doesn't really clean up the resources, and obviously we don't want to keep, our build racking up in the background. So let's quickly go ahead and just queue the destroy plan and kind of clean up all the resources that we provisioned during our first apply in the test 2 workspace here. So as the plan runs, we're going to notice that it's going to connect to our AWS provider, it's going to check for the resource that we have, and it's going to produce a plan saying that it's going to destroy 3 resources, exactly the same amount we provisioned before, and then it's going to end up with a clean account afterwards where our resource is going to be cleaned up, and we will be in a position in order to remove the workspaces in Terraform Cloud. So let's go ahead and approve the plan and trigger the apply stage here. So this run will actually go ahead and apply the destroy. So it will remove all the resources. But as this is going ahead, let's quickly switch back to our console and open the terraform.auto.tf again. And let's remove whatever we enabled before. So let's remove the trigger and both of the workspaces now. And again, let's commit that to the repo and push the changes back in, which will trigger again the Terraform Cloud run for the configuration workspace, TFE-workspace in our case. As you can see here, it already started planning. So let's go ahead and see the plan output. It should be fairly quickly as it's only connecting to the API in its local instance. So as you can see here, it's actually planned out of destruction of 9 resources, exactly the same amount that we provisioned before. So it's going to remove the triggers, variables, and all the workspaces that we provisioned initially. Okay, let's go ahead and trigger a plan. So as this is running, let's quickly go back to the workspaces and see what's happening here. So as soon as this runs and it connects back to the API, it will go and remove all the workspaces programmatically, as you can see here. So to summarize, by using TFE Terraform Provider, we definitely increase the deployment velocity and automation while provisioning Terraform Cloud workspaces. It definitely helps us to reduce the friction rolling out the infrastructure changes while using infrastructure as a code approach, and thus utilizing the HashiCorp configuration language version 2. So there was no need to kind of adopt a different kind of approach or learning an API which would be needed to configure those using the programmatic access. And while the Terraform TFE provider is still beta and subject to change and still at the version 0.26, it proved to be quite stable, and a lot of our customers actually successfully adopted it and using it in production in order to provision their highly scalable and elastic Terraform Cloud infrastructures. If you're operating in more of a cloud native space, or if you're using Kubernetes for running your workloads, there is also a Terraform Cloud operator, which is a little bit different than TFE provider. But as an interesting kind of information here, you can use that and use cloud native manifests and CRDs in order to provision your Terraform Cloud workspaces as well. So there are alternatives to kind of, provision and configure your Terraform Cloud or enterprise using the cloud native constructs here. So by using Terraform Cloud TFE provider and modularizing for reusability, we use the GitOps paradigm here, where all the changes are centrally managed and triggered from our Git repo. And we believe that kind of this brings our Terraform runs closer to a commodity, such as, for example, electricity, where you just expect it to be there and it just runs without you needing to know all the nitty-gritty details and how it works in the background. With that, I'm going to leave you with some additional reading if you're interested in learning more about the topics we covered today. And please do keep in touch using all the social platforms or the Q&A session after this. And thank you for listening, and I hope you enjoy the rest of your conference.